Okay, Algebra 2 fans, today we're going to start talking about polynomial graphs and what they mean and how do they look. So the first thing that we want to look at is, let's talk about the degree of the equation. That's right. This polynomial graph right here, notice all the exponents are in descending order, 3, 2, 1, then there's no exponent. Technically there is. It's an x to the power of 0. Okay, remember, anything to the power of 0 is 1. X to the power of 0 is 1. Okay, so that's why we don't see it. So 3, 2, 1, 0. Okay, so what is the degree? The degree is simply the largest exponent that we see. And that third, because it's a degree of 3, we have 3 possible roots. Okay, so this means we're going to have 3 roots, or 3 x-intercepts, okay, or 3 zeros. All of those mean the same thing. Roots, x-intercepts, zeros, they all mean the same. Right? This is a 4th degree equation. So we're going to have 4 roots, or 4 x-intercepts, or 4 zeros. Okay? Now, what do these graphs look like? First of all, any even degree. You guys have graphed even degrees. Those are called your parabolas. So any even degree, okay, and with a lead positive coefficient, okay, with a lead positive coefficient. So in other words, the number in front here is positive. So usually that's our A value. So that A value is greater than 0, okay? Our graphs, I say, high to high. Think about what a parabola looks like. Think about what y equals x squared looks like. That's right, it's a U. Okay? If there was a negative in front here, then it's upside down. That's all. So now a 4th degree equation, and let me say it this way. So a 4th degree equation looks like this. It starts high, and it passes, and it has a little squiggle inside here. So it's going to cross the x-axis in 4 places. 1, 2, 3, 4. It has a potential of passing in 4 places. A second degree passes an x-axis in a potential in 2 places, or we could repeat. And then, right, a 6th degree, I mean, starts high, does its squigglies in here, and then finishes high, as long as the lead is positive. So high to high. An odd degree, so we usually don't graph odd degrees up until now. So this is what a 3rd degree equation looks like. Okay? Notice it starts low, finishes high. So again, lead positive coefficient, that means that A value is greater than 0. What it means is it goes low, starts low, so as I read from left to right, it's low to high. Okay, so that's what a 3rd looks like. We're just going to do, well, actually, I forgot a 1st. Here's a 1st degree. That's right, a line. Right, starts low, finishes high. Think about a positive slope. Up 1 over 1, up 1 over 1. Okay, 3rd. And then here's a 5th. We're not going to graph 5ths. Okay, so you won't have to worry about that, but they would look like this. They would just have more squiggles. Okay, that's right, a 5th degree would cross the x-axis in 5 places. 1, 2, 3, 4, 5. Has the potential of crossing 5 spots. All right, now, look at my examples down over here. I have this thing in factored form. This is a polynomial in factored form. Okay, we need to know what the degree is. We need to know if the lead is positive, and then we'll need to know what the roots are. And then we'll easily be able to do a quick sketch. So the lead is positive. That's right, the lead is positive. What degree is this? Well, it's not written out like this, but if you look at all of your x's, okay, this is x times x times x, so that's x to the power of 3, so this is a third degree. So it's going to look something like this. It's going to start low, do its squiggles, finish high. What are the roots? 3, remember, opposite, so the roots are 3, a negative 4, and a 1. We don't care about y-intercept. Here's a quick sketch. This is all I'm asking you guys to do in your homework is do a quick rough sketch. Neatly plot your points. So 1, 2, 3, 4. Put a big fat dot. Here's 1, and there's 3. And a rough sketch is this. We know it's positive, so it starts low to high. So we start low here, and we go hit negative 4, and then we have to go hit 1. You don't go straight across. You go, make it loopy. Make it loopy. Go hit the 1. We don't go straight across. Make it loopy, and finish and hit the 3. So I just did a rough sketch. That's all I want is a rough sketch. Doesn't have to be pretty. All I want to make sure you label your intersection points. Neatly label your intersection points and put them in numerical order. You don't put positive 1 here, and negative 4, and then positive 3. All right, let's start with this one. What's our lead? Right, the lead is positive. All right, we need to know what the degree is, and we need to know what the roots are. So the lead is positive. That's right, there's no negative sign in front there. Now, the degree. Well, this says x squared times x times x. That's x to the power of 4. So this is a 4th degree equation. So here's a 4th degree. We start high, do our squiggles, and then finish high. Okay? What are the roots? All right, this squared says we see this thing twice. So I have a pair of 2's. Then I have a 5, and then I have negative 1. Remember the roots, set these equal to 0. You see 2 of these, a 5 and a 1. So these are your roots. Now all I got to do is put this on the number line. Or, sorry, on a graph. So here's negative 1. There's 2. Put a dot there, put a dot here. You don't put 2 dots here, you just put 1 dot. I'll show you what it looks like. And then 3, 4, 5. All right, now, this 2 is a repeat. I call it a bounce. I call it a bounce, and I'll show you what this bounce looks like. So, first of all, we have to start high. It's a 4th degree. 4th degree, start high. So that means I start up here. And now I go through 1. Okay? I go through 1. Now I have to go hit 2. I have to swing and start hitting. Make it curvy. Okay? Now I go hit 2. But I don't go through 2 because 2 repeats itself. It's a bounce. So you make it bounce on 2. There's a bounce on 2. It doesn't go through it. It hits 2 and it comes right back down. And now I make it curvy and I have to go hit 5. There, I made it nice and curvy. That's right, your 4th degrees tend to look like a W or something that looks like, that could resemble a W. Okay? Nice job. All right, we got 2 more of these, and then I have actual pictures that we're going to look at. All right, now notice this one has a negative in front. So what degree? So our lead is negative. So we have a lead negative. So that means we're flipping. Okay, the degree and then the root. So what's the degree? Degree. I have an x to the power of 1 times an x squared. That means it's a 3rd degree. And what are the roots? Well, remember we set each equal to 0, so that means x is equal to 0. And then this is 3. How many times do we see the 3? Twice. So in other words, we have another bounce here. So I have a root at 0, and then I have a root at 3. All right, now, remember, odd degree, supposed to go low to high. But what happens when we have a negative in front? There, that's right, your picture's just flipped over. Think about your parabola when you had a negative in front. It's not a happy face, it's a frowny face. It's upside down. So here, we're not going to go low to high. We're going to start high and go squiggles and finish low. So this is a third degree with a negative, so that means we go high, do your little squiggles, and we finish low. Well, there's 0 right here. I have to start to the left of 0. I start high. I have to go hit 0. It's not a good job of hitting 0, but that'll do for me. Remember, make it curvy. We have to go hit 3 now. But what happens at 3? We bounce at it. So we bounce at 3, and then we finish low. We started high, came through 0, and we swung and hit 3, and we went low. That's it. That's all we have to do. So this negative went high to low. Okay? Our last one. Again, a negative. That's right. So lead is negative. All right. Degree, and then the roots. All right. So what's the degree? And here we have an x squared, and then x and an x. So that's a fourth degree. Remember, x squared times x is x to the fourth. Now the roots. That's right. That means 0 shows twice. And then we have a -2, and then we have 3. Remember, for your roots, you set each of these equal to 0. So that says square, so we're going to see it twice. So I'm going to see 0 twice. Then we got a -2, 1, 2. And then I have a 3, 1, 2, 3. Okay. All right. So remember, an odd degree, low to high. And that's as long as we have a lead positive. So that's right, when we have a negative in front, we're not low to high. We start high, do our squiggles, and we finish low. So with this lead negative, that means we go high to low. Everything's flipped over. So I start, and now look, here's -2. I have to start to the left here somewhere. So put a little arrow pointing high, and now I have to go hit -2. So now I'm going to go hit -2. Does it bounce at -2? No, it only appears once. We have to go through -2. Now I have to go hit 0. I have to go do some curvy. Do we go through? No, 0 repeats itself. So we bounce, and now I go curvy and I hit 3 and finish. Oh, I made a mistake here. What did I do? Oh my goodness, guys, I'm so sorry. What did I do? This is a fourth degree equation. Oh. This is a fourth degree equation. We're low to low. Wow. Wow. Why am I? Now let's do that again. We have 0, 1, 2, 3, 1, 2. All right, let's try that again. Oops. All right, low to low. We start low. It's an upside down. Go through, bounce. There we go. Oops. So my W now looks like an M. Perfect. All right, I'll let you digest for a minute. All right. Now let's some graphs. So now we're going to write these things in factored form. We're going to identify the polynomial equation for each sketch. We're going to leave answers in factored form. So the first thing that we have to do is we got to go through here and figure out what the roots are. So that's each of these little tick marks are ones. Okay, I did that. I made them nice and big for you to see. Okay, so that's a 1 here. That's 2 right there. So that's 2, negative 2. How many times do we see that negative 2? That's right, we see it twice. I don't know, whatever you got to do to write it for yourself twice. Then this is 1, 2, 3, and then this is 4, 5. Okay. What degree is this? I have 4 roots, so it's a 4th degree equation. That's right. So we're going to write in the equation means we're going to say y equals or p of x is equal. I'm going to use p of x. P for polynomial.